Hello, so today I'm looking at M3 International A-Level January 2015. This is question 6. So we begin with a smooth sphere with centre O and radius A is fixed with its lowest point A on a horizontal floor. A particle P is placed on the surface of the sphere at point B, where B is vertically above A. So if I just begin by trying to draw a little sketch of what this looks like. So the centre is O. The radius is A, and the lowest point is called capital A, which is on the floor, and the highest point is called capital B, which is vertically above A. The particle is projected from B with a speed of this, and moves along the surface of the sphere. When OP makes an angle of theta with the upward vertical, and P is still in contact with the sphere, the speed of P is V. So if we draw this line and then just choose a random position here for the particle to be in, we'll call this theta, and at this point it said the speed was V. And it says show that V squared is equal to this thing. So what I can say is that there will be a conservation of energy. So I will have that basically the kinetic energy that there is at B plus the gravitational potential energy at B will equal the kinetic energy at this other random point over here. So I'll call this C plus the gravitational potential energy at C. What I'll do is, just to make things a bit easier, I'll say that this level of O, gravitational potential energy is 0 along this level, so that everything, all of my heights are measured from here. Okay, so I've got half times the mass, which they didn't tell me, so I'll just call that M, times the initial speed squared, so that will give me AG over 5, squaring this, plus mg, and the height there will be A, equals the kinetic energy at this position, so half mv squared, plus the gravitational potential energy that there will be here, which will be, if this is A, I consider that the hypotenuse, then I'm looking for the adjacent here, this height here. So that is A cos theta. And I need to multiply that by m and g to end up with the gravitational potential energy. Okay, so rearranging this, then I end up with, well, I've got m's everywhere, so I could first of all divide everything by m. I could multiply everything by 10 to get rid of this fraction here. So if I multiply by 10, this will disappear. Then I need to multiply by 10. If I multiply by 10, that will become 5. And if I multiply by 10, that will become 10. And so I've got 5v squared will be equal to AG plus 10AG, so that will leave me with 11AG. And over here I've got 10AG cos theta. So rearranging this to make v squared the subject now, I get 11AG minus 10AG cos theta, and then the whole thing is divided by 5, so in other words multiplied by 1/5, and that gives me this expression for v squared. Let's compare it to what they had. Okay, they've got the same thing except they've got AG over 5 outside, but other than that it's absolutely identical, so I'll just rewrite it as they did. AG over 5, 11 minus 10 cos theta as required. Okay, so that is your first few marks, that's part A. Then it says the particle leaves the surface of the sphere at point C. Find the speed of P at C in terms of A and G. Well, when it leaves the sphere, I know that the reaction at that point is 0. So if I just draw what the forces are at that point. So here I've got theta, this is A, the speed is V. Now, what forces are acting? Well, I know that the weight is acting down. I know that there's a reaction force here. And I know that it's accelerating towards the centre of the circle. For the acceleration, you can always use r omega squared or v squared over r. And in this case, I'm going to use v squared over r. So in other words, v squared over the radius of the circle, which in this case is a. So if I do Newton's second law towards the centre of the circle, then I get the forces towards the centre of the circle. So mg, now using alternate angles, this is theta. So I get mg cos theta minus r equals the mass times the acceleration. But at this point where it's about to leave the surface, it's about to leave the surface at point C, the reaction force will equal 0. And so therefore I end up with mg cos theta equals mv squared over a. I can divide both sides by m, and I can multiply both sides by a, so that I get ag cos theta is equal to v squared. So now I can put this together and this together to be able to work out what theta is. So I'll call this 1, I'll call this 2, and so I'm saying 1 equals to 2. So I end up with ag over 5 times 11 minus 10 cos theta equals this thing. I can divide both sides by ag, multiply both sides by 5, and then add 10 cos theta to both sides. And then divide both sides by 15. So I end up with cos theta is 11 over 15. Just let me check what they wanted. They said find the speed of p. Okay, so once I've got what cos theta is, I can pop that into here to work out what the speed is. So now that I know cos theta, I'll pop that in here. So equation 2 now gives me that v squared is ag multiplied by 11 over 15. So therefore the speed is the square root of 11ag over 15. Okay. Now in part C, I'm being asked to find the size of the angle between the floor and the direction of motion of P at the instant immediately before P hits the floor. So when the particle leaves the surface, then I know it's acting in this, it's moving in this direction. So I know that the horizontal component, there's theta, that's not theta, this is theta. These two add up to 90, these two add up to 90, so therefore that is equal to that. So I know that the horizontal component will be v cos theta. So as it leaves sphere, v horizontally will equal my v multiplied by cos theta. So the value of v was, I just found that in part B, that was 11ag over 15 square rooted. Cos theta was 11 over 15. And so that gives me, as it hits the floor, so v horizontally will remain unchanged, because horizontally, as it's moving freely under gravity, there will be no acceleration whatsoever. So that velocity will remain constant. So that is there. So I can find the angle between the floor and the direction of motion, because the direction of motion will be something like this. And so basically there's the floor, and so the angle that I need is this. Let's call this phi. So if I can work out what the magnitude of the speed is, then I could use inverse cosine to work out what this angle is. So here, let's work this out. Let's call this x. So using energy, I know that the energy that it had at C, the kinetic energy, plus the gravitational potential energy at C will equal the kinetic energy as it hits the floor. So let's call that F, floor. And this time I'll take the floor to have no gravitational potential energy. So the kinetic energy at C was half times the mass times the velocity squared, and we found at C that this was the velocity. So I've got 11 ag over 15 plus the gravitational potential energy at C. Well, at C it's up here compared to the floor. So I've got mga plus mg times this height here, which is a cos theta, which was a times, and cos theta was 11 over 15. Okay, so that's the gravitational potential energy at C compared to the floor, which is down here. And that will equal the kinetic energy at F, which is half mx squared, when I've taken the speed that it hits the floor with to the x. So dividing everything through by m, I get this. Okay, I need x, so let's double everything. So double, double, double. Okay, let's tidy this up a bit now. So here I've got 11 ag over 15. Here I've got 2 ag plus here I've got 2 times 11, so 22 ag over 15 equals x squared. So adding up all that stuff, I've got 11 fifteenths plus 2 plus 22 fifteenths, and that gives me altogether 21 fifths ag. Will give me x squared. So to work out x, I just need to square root that. So here I've got x, here I've got v cos theta, and so in order to work out the angle that I need, which is phi, it will be inverse cosine of the adjacent over the hypotenuse. Now the adjacent was v cos theta, which was this. Divided by the hypotenuse, which is this. So if I'm dividing by this, I'm multiplying by the reciprocal. So the 21 ag ends up on the bottom, the 5 ends up on the top. And so now these ag, or it's root a, root g, will cancel from the top and the bottom. Here I can divide a 5 and a 15. Or it's a root 5 and a root 15. And so this is a bit of a mess, but basically I can either just stick all of that on my calculator to work out the angle, or just tidy it up a bit. So all the things in square roots. On the top I've got 11, on the bottom I've got 3 times 21, which is 63, and that's in a square root, multiplied, and I've still got the inverse cos. So that went together with this there, and now that's multiplied by 11 over 15. Okay, so popping that into my calculator, I've got the square root of 11 over 63, and then outside of the square root I've got 11 over 15, and inverse cosine of that value 0.3 gives me 72 degrees to the nearest degree. Okay, so that part of the question was worth 5 marks. So altogether you've got 4 plus 6 plus 5, so you've got a total of 15 marks for that question. Okay, I hope you found this solution helpful. Good luck with your studies.